Good morning. We're going to be talking about lighting in the iRVision 2D vision system. We've been working on the robot down in the lab, and I just want to review some things that we're going to be talking about and using in 2D calibration, particularly lighting. So one thing we can review would be your calibration grid. And we all know that you do have some different sizes here you can use. This is a 30 millimeter one that they sent from Fanuc. There's actually various sizes you can get. But when you set this up, this is X here. So you want to make sure that you're running on X when you're looking at the robot or standing in front of it, and then Y. So when you look at the screen to calibrate, we can make sure that we're getting all of these dots in place and in the field of vision of the camera. Okay, so make sure that you are running X and Y when you set that on your robot. It's very important. It can be a little bit crooked, but I like to try to get it halfway straight if I can. So it can pick up these four big dots here, like we talked about. That these four dots are pretty critical to the vision system and how it reacts to calibration. And we can go back, and when we set up the 2D calibration, we can actually go in here and add or subtract dots over here that ain't quite coming into vision. So we can delete those if we want to. But really, when you get one of these, you really want to have the piece or the feature fit into this grid. So it does have to fit into the grid. So we're going to talk about lighting. I did visit with Boeing, and you know, there's several of our guys working over there, and they're kind of new into the whole robotics field. It seems strange because you think that Boeing would be pretty big into that system, but they're actually a green field. So basically, I can't remember his name, Jim from Boeing. He travels all around to all the plants around the area, and he'll take and identify a process that he can use robotics in. They set up a process particularly for lighting in iRVision in one of their plants. He got it all set up in the lab. Everything was good to go. All the lighting was right. Lighting over here, lighting here, behind lighting. They took it out to the lab or out to the show they were going to run, basically picking and placing parts, identifying different colors in the program or in the lab they're working in. Got it in there to come to find out they had lights that shut off and on because they were outside in Phoenix somewhere. So the lights would shut off and on. So what's that doing? Well, consequently, if the lighting doesn't stay the same or isn't variable or isn't the same all the way through, you're going to have some major issues with lighting. I've seen some videos on the internet where they're stacking hot dogs or meat sticks, and all the lighting was just perfect. They'd take a picture, move down the conveyor, grab another meat stick, and put it in a package or make it straight, and they were able to package that. But that lighting was so controlled that it's very important that we make sure the lighting is right. So we're just going to go through some of the hints that we can do that you might see in industry, or even in here when we start to set up our lighting for our iRVision. So we have a light spectrum. We all know that the camera can actually pick up light that we can't see. So we can only see so much light. The camera can actually pick up light better than our naked eye can. So you can use filters, you can use different lenses, filters, things like that, cameras, to make it better iRVision so that it can pick up our this light spectrum. So if we look at this is our camera, and you can see that we have a bright field. So this is what the camera's seeing. Over here, a dark field is what the camera can't see. So if we have to, if we're dark field lighting, it illuminates the part with indirect lighting. good for finding edges. So if we have indirect lighting, so if your light source, this happens to be a ring light that would actually mount here, so all the light's going down. So let's just set this up or make a fixture or something so that it is here now. It can be here. Now that it can pick up edges of the part. So some of these are just common lighting solutions that we could come up with. That we can, that's just one example. Here's another one. Bright field lighting solutions eliminates the part. With direct light, good for finding surfaces. So it wants to find edges, it wants to find surfaces, and we'll talk about contrast and how important contrast plays in this whole role of lighting for the iRVision. Here's one that's backlit, so illuminates the part from behind the part, good for finding silhouettes. So if you have a part that's here that's translucent, maybe like this little guy here, this plastic plate, and it has maybe some sort of microchips or something, who knows? You can light from behind and it'll actually go through the part and it can actually pick up features then. So this would be a behind the light, behind the part. Good for finding silhouettes. Machine vision is all about contrast. So we think about that. What's contrast? What is contrast, do you suppose, Quinn?
Difference between like light and dark?
Yeah, difference between light and dark. You know, I have a kind of a big belly. You guys don't have a big, you know, you're skinny or young. That would be a contrast, right? So contrast is to show difference in the part, differences in the part. So this might be sitting at some angle. The contrast is greater here because it's like a light surface, darker over here. So we're trying to find contrast. It's super important. So a successful vision application is almost all about creating optical contrast between the feature of interest, the part, and the background. Contrast is achieved most commonly through proper lighting. Lighting and optics are 80% of any vision application. Like we talked about, we're trying to find a location of a bolt, or how this sausage is sitting in some position here so that I can tell, hey, it's sitting in this position, I need to make my gripper go this direction. So we can actually write a program so I can tell how that part is sitting there. So if the robot can see that through iRVision, the better. If you don't have good lighting, the robot can't see what's happening. So it's all about the part, the lighting, and your system. So how is contrast achieved? What optical properties can be used to create the contrast between a part or feature in interest of the background, right? Shape, surface texture, color, translucency. What's translucency?
How clear it is?
Yeah, how clear it is. You know, the type of color is it black? Is it red? Is it yellow? Is this battery going down the system here and they forgot to put two caps on top? One's red and one's black. The system says, hey, wait a minute, it forgot one of the caps. Grabs that battery, moves it over here to the reject pile. Somebody comes along and says, hey, that's rejected, let's see what's going on with it. Well, it forgot a cap. So the system can do that. What shape is it? What's the surface texture? And what the color is. So those are all important things you're probably going to need to know for the test. So go ahead and write that down. It's a good idea to know these, that the shape, surface texture, color, and translucency are fairly important to an iRVision system. Part analysis, shape. What techniques can be used to highlight differences in the shape? So let it catch up here. So you have backlight, you know, like backlight here, lighting the part. Directional light using area light. So hey, it's a big area that we're trying to illuminate. This is our ring light, so we can actually attach this to the right to the robot. And when you start to do the 2D calibration, it asks you, where is the light sitting? Is it attached to the robot? Is it off axis? Where is it? So it's going to ask you those questions as we go along. So low light, low angle light. Hey, maybe we're going to put this light here so that we can see the part here at the top of this table. On axis light, laser light generator. I got to look this one up. I'm not sure about that one, so we'll do a little research on that, but that's okay. These seem to be the most common right in here. I think this system's pretty expensive. So we have our backlight, directional light, low angle light, and on axis light. Surface texture. What lighting techniques can be used to highlight the differences in texture? Okay. So we're going to use these three. Directional lighting, maybe a ring light, direct. Low angle light, again this way, right? We're going to do this for a low angle. On axis light. So let's check that out. Part analysis. If we illuminate this flat shiny surface, will the camera see the light? No, the light will reflect at the angle of incidence. So here's the light reflecting off that shiny surface, so it won't pick that up. If we eliminate the diffuse surface, will the camera see the light? Yes, but only some of the light. So we're contrast, right? We're trying to pick up as much contrast as we can in the part for the iRVision. So a microscopic view of that would be something like that. So here's some surface texture and geometry. Light method, directional light. So if we have directional light, a smooth surface appear bright. Directional light, rough surface appear dark. Okay, so rough surface. Maybe if we have a bad surface finish, or we have something that's pretty rough on the surface, we can apply the directional lighting, and this is what the robot or the iRVision is going to see. So directional dark field would be light for smooth surfaces, dark for smooth surfaces appear, rough surfaces appear bright. So, low angle, what's low angle? That's down here again, right? Low angle, so that way. So smooth surfaces appear dark, rough surfaces appear bright. On axis, the ring light again. Watch out for this light. That's a ring light. Goes on your robot. Camera's over here somewhere. We gotta make a fixture for that. Watch out for that. If we bash, this is $650. So kind of be careful when you start to do the iRVision that we're moving this into something that's going to knock out one of these LEDs here. Pretty expensive light, so we'll be careful of that. Part analysis. I do have another slide here. I wanted to show that. Kind of a cool. This is out of your big book. I don't know if you can see it very well, but that's kind of cool. Just to review, the main goal of lighting in a vision application is to create contrast between the part and the background, right? Got to make we have a background sitting here. How can we make that part stand out and be different? So we have a backlight, okay? We have a directional light off to the side, a ring light like you talked about, low angle light, diffuse light, and on axis light, okay? So if it's on the Y, it could be over here or over here a little bit. So shape, examples, notches, stampings, embossings. So backlight will highlight outlines and profiles. Directional light will cast shadows to highlight height changes, right? So we can see height changes. The ring light isn't going to be very good for these bosses and stampings and notches, so we wouldn't want to use that one. Low angle light is height changes are bright, flat surfaces are dark. So it's a low angle light, and the diffuse light, lower contrast between shapes. So you can kind of see how that chart works. If we go to surface texture, that's our next one here. And this is in your book, so you don't have to write it down. You're okay there. I like this chart because it's, hey, here's what I got. Now look, I'm trying to find this. Oh, it's not finding it yet. Okay, let's go to this chart and say I need a ring light. I need some light over here to show more contrast. So surface texture, polished metal, sandpaper. I mean, if we have some chrome parts or we would have ground a piece that we're trying, or pieces that are sitting in something, a container that we have to move to deburring or whatever it is, it can pick that up. So, hey, a backlight probably wouldn't work to get that because we're trying to pick up that shininess. Directional light, cast shadows. Oops, we gotta move down here. Texture surfaces are bright. Smooth surfaces are dark. Ring light again. Ring light seems to be a little bit small usages. So low angle light, diffuse surface are brighter than reflective. Diffuse light, lower contrast between reflective and textured surfaces. I've even actually seen in the book where they have, if you have too much light happening, you can actually put in some sort of blocks that block that light from coming up. So you only want this little area where you see your little vice jaw here, but too much light is being reflected maybe from your surface. I can put little blocks over here so it only accepts so much light, maybe a piece of plate or something, or a piece of wood, a paper, or something there that would work for that. You just kind of have to mess around with that. Let's look at this thing and see what a ring light. Oh, here's a ring light. That's what we have. Color. So based on target color. So ring lights are handy, but it seems like your other type of lighting is going to be of better use. Did you have any questions so far about the different types of lighting?
Would the ring light still be okay for if you've got like a white background and you're dealing with dark parts?
I think we're going to have to mess with that. That's actually one of our exercises that we're going to do. So as we start to go through the color, there's actually some of the PowerPoints we're going to do are color. So yeah, you have white. Like when I went through the training over there in San Francisco, we actually put a pad down, a blue hand towel, and we got rid of the white. So the white was kind of a problematic for that part that we were trying to find. So as we go through that, you'll see that the darker, that at least for this application for the ring light, was that pad underneath really helped try to find that part as we were setting our, 3-point and 4-point methods for calibration. So what we'll do is we'll go ahead and take a break, and we'll come back and we'll talk about color. Thanks.